Good morning. Good morning, students.
Good morning, sir. Good morning,
Good
sir.
morning.
Last class we had a discussion about computer vision. Uh, we had an introduction what is computer vision is. As you know, it is nothing but it is used to it enables computers to interpret the extract information from image and videos similar to one human perception. That is, you know that when we view an image, uh, we can get some information from it. When we see an image, when we see a video, we know that that is this is suppose we see a picture of a tree. We know that this part is the leaf of tree, this part of the is the fruits, this is the flower of tree, these are the branches of tree. So we know that, and we get information about that. So how does the computer will view it? How does the computer get information from an image or a video? That is called the computer vision. And computer vision involves some algorithms. That is, it has some algorithms by which we get and derive some meaningful data, some meaningful information from an image or video. So we already discussed why learn computer vision, high demand in job market, revolutionizing industries, solving real world problem, public safety, improves medical imaging, and optimize industrial process. And high demand in the job market, essential for careers in AI. You know that nowadays AI, ML, artificial intelligence, and machine learning are very demanded uh, uh, career, and most of the students now they are doing or learning AI ML course, and it is better to get a job. Getting a job in this field is demanded, and easily you can get. And uh, we had some application, that is, you see, have you ever how machine can see and understand the world around them? We have our human eyes. No, when we seeing an object, we got some information. But you think about the machine. How does the machine see? How does the machine understand the world around them by viewing the image? So a computer vision is nothing but it's a branch of artificial intelligence that enables computer to interpret and analyze digital image, video, and other visual inputs. So uh, it how does the machine read it? How does the machine interpret and analyze digital image, video, and other visual input? So, for example, from self-driving cars to healthcare diagnostic, computer vision is revolutionizing industry by allowing machine to recognize object, track movements, and even make decision based upon what they see. So these are the applications. Other application are, we will discuss oil and natural gas. Uh, um, to find the location, they have to analyze thousands of different location. That is, the geologist have to analyze thousands of different locations using image taken on the spot. It is not easy for them to analyze by traveling physically of each spot. So it is easy for them uh, uh, sitting their home. They are analyze the images and videos of different locations, and uh, take a decision. So if the geologist had to analyze the each image manually, they have to take long time to find a best location. Maybe months, maybe more than 1 month can be taken, even if even a year. So But due to the introduction of computer vision, the period of analyzing can be brought down to a few days, even few hours. So they can solve this problem by taking a few hours or few days. Similarly, hiring process also is huge. The HR world computer vision is changing how candidate get hired in the interview process. So if the number of candidate is large, so uh, by using computer vision, machine learning, and data science, we are enabled to quantify soft skill and conduct early candidate assessment. We can conduct an early assessment to help large companies shortlist their candidate. Besides that, video surveillance. The concept of video tagging is used to tag video with keyword based on the object that appear in the each scene. Now imagine that the security company who asking to look for a suspect in a blue van among hours and hours of footage. It has to feed the video to the algorithm with computer vision. The object recognition searching through video has become thing a past. So it is also used in security companies. Suppose they are looking for a blue vans. So by computer using by computer vision and object recognition, the search can be successful. Also in healthcare construction, we have already discussed that is if there is a tall building or towers, manually by climbing up to the towers to look at every inch and every corner would extremely time consuming and costly and also risky, dangerous. So uh, mm, that is why we have taken a person in ground. The person on ground took high resolution image from different angles, and the computer vision specialist could create a custom classifier and use it to detect the flaws and amount of rust cracks present. So without climbing up manually to the tower and looking at every inch and every corner of the building or of the tower, it is not only time consuming, but it is also costly and risky. So instead, we have to take a high resolution image from every corner, and a computer vision specialist would classify and detect the flaws of the amount of the rust cracks present on it. uh, Healthcare. So the healthcare industry has adopted many next generation technology that include artificial intelligence and machine learning concept. One of the computer vision which helps determine or diagnose disease in human or only living creature. So the computer vision, one of the most application is it helps and determine and diagnose the disease in human body. The agricultural farm have started using computer vision technology in various forms, such as smart tractor, smart farming equipment, that is grass cutter also there, farm grass cutter are there, that is they are used to cut the grass uniformly in your garden. You need not to operate it manually. You have the sensor, your uh, remote controller. You can control by sitting in your lawn, and smart tractor are there, smart farming equipment like your grass cutter, and drones to help them monitor the maintain the field efficient. There are drones having cameras, that is if the field is in a large quantity, it is not easy to uh, um, monitor each and every part of the field. So the drones are used to help them monitor and maintain the fields efficiently and easily. It also helps improve yield and the quality of the crops. So the computer visions, they also have an application in agriculture, military. For modern armies, computer vision is an important technology that helps them to detect enemy troops, and it also enhances the targeting capability of guided missile system. So by sitting in your home own country, you can guided the and target the missiles in other part of the other countries. It use imagine sensor. It use image sensor to deliver battlefield intelligence used for tactical decision making. So it is use image sensor for that purpose. Uh, Industry in manufacturing or assembly line, computer vision is being used for automated inspections, identifying defective products on the production line, and for remote inspection in machinery. The technology also used to increase the efficiency of the product line. That is, the computer vision is used to automated inspection. Some part of the machine is damaged, some part machine is overheated, some part machine is not working as per its efficiency. So it identifies the defective products also. This product is defective. So on the product line, and for remote inspection of the machinery, that is you can see it in your office and you can uh, monitor the machinery. The technology is used to increase the efficiency and the product line. Obviously it can use the and enhance the efficiency of the machine. Automotive, this is one of the best example of the computer vision technology, which is the dream come to true for humans. Self-driving AI analyze data from a camera mounted on the vehicles to automated lane finding, detect obstacles, and recognize traffic signs and signals. So it is automated uh, camera AI analyze data camera is mounted on the vehicles, so it can detect the obstacles. That if there are obstacles, it will detect that. It will come the eyes up or to the driver, that it is get the it let the information to the driver, so that the driver take the necessary steps. Automated lip reading, this is one of the practical implementation of computer vision to help people with disability or who cannot speak. It reads the movement of lips and compare it to the already known movements, so that were decoded and used to create the model. So it read the, are the name suggest, lip reading. It read the movement of your lips and compare it to already known movements. And so it is also another important application of computer vision. So these are the uh, uh, 10 computer visions applications. Computer visions are used in different fields, which we have already discussed. So let us see to start how the computer visualize it, or how to computer get information from an image or from a video. We have to first learn what is the process of image formation. How image is formation? Image formation is an analog to digital conversion. We already know that an image is a digital analog image, but when you take in your camera, so it is converted to a digital form. So that is why it is written is analog to digital conversion of an image with the help of 2D sampling and quantization. Please recall, we have already discussed to, to convert an analog form to digital form or analog signal to digital signal. We had two important process. One is sampling, by which the position of an image is determined, and quantization, by which the gray level value or color value of that pixel is determined. So sampling and quantization plays a vital role in converting an analog signal to digital signal. So these two techniques are used, sampling and quantization, that is done by the capturing device like camera. we see that a 2D view of a 3D world, because uh, a, uh, uh, a 2D view, that is when we capture an image, our screen is a 2D dimensional 2 dimensional screen. It has x axis and y axis, but an image is a 3D. Okay, so that is why written we see a 2D view of a 3D world. In the same way, the formation of the analog image took place. It is basically a conversion of 3D world, that is our analog image, to a 2D world, that is our digital image. So you can, other word, we can say that it is a conversion of 3D world to the 2D world. So a frame grabber or a digitizer is used for sampling and quantization of the another signal. So as we know, to convert an analog signal to digital signal, we had two techniques: one the sampling and its quantization. So sampling is used to determine the location of a pixel, and quantization is used to determine the gray level value or picture value of a pixel. So for that purpose, a frame grabber or digitizer is used for sampling and quantization of analog signal. As we know, you see, next topic is imaging. As we know, uh, uh, analog image, an image is a 3D world, but when we capture the image, it is mapped to our 2D screen, our camera screen, or our cell phone screen is a 2D screen, two-dimensional screen. It has only two coordinate x and y, but actually an image is a 3D world. It has a length, breadth, and height. So the mapping of a 3D world object into a 2D digital image plane is called imaging. It's called imaging. So imaging is nothing but mapping a 3D world object, an image, to a digital image plane. Our screen is a digital image plane. It is a two-dimensional plane, but an object is a 3D world. It is 3D. So the mapping is called imaging. In order to do so, each point of the 3D object must correspond to the image plane. So each pixel or each point on the 3D object must be corresponding to the image plane. Optical systems. The lens and mirror are crucial in focusing the light coming from the 3D scene to produce the image on the image plane. So when we capture a picture, the lens or mirrors are also plays a vital role, a crucial role, because it is focusing the light coming from the 3D scene to produce the image on the image plane in the 2D plane. This system defines how light is collected and where it is directed, and consequently affects the sharpness and quality of the image produced. So this system will determine that how light is collected from the 3D scene, and it directly and consequently affect the sharpness and quality of the image produced. So obviously this is the region which depend upon the sharpness and quality of the image. The goal of image sensor like the CCD or CMOS sensor are to simply transfer the optical image into a electrical signal. The sensor differ by the sensitivity, the resolution that they deliver affecting the image as a whole. So image sensor also. So we have already discussed the two component resolution. The resolution is defined as the sharpness of an image, and it occurs technically as the number of pixels an image can hold. The number of pixels in a unit place. The number of pixels in an image is called the resolution. If the number of pixels is more, if the number of pixels is more, the picture quality is better. If the if the pixel size is larger, the number of pixels in an image is less, which reduces the quality of the picture. So the resolution means nothing but it is the number of pixel in an image. You consider, suppose the size of the pixel is large, an image contains less number of pixels. If the size of the pixel is small, an image contains less number of large number of pixel, which gives a good quality picture. Sampling is the act of taking samples or discretizing the digital signal and represent a continuous analog signal as a group of discrete value. As you know, this is the sampling. It can be seen that higher resolution and appropriate sampling rates are required in order to provide detailed and accurate image. So it gives the guarantee that is we have to get a higher resolution. The higher the resolution, the better is the quality. Uh, Image processing can be described as the act of modifying and enhancing digital image by using algorithms. We have already known that from a first class, that is image processing is nothing but it is act of modifying or enhancing the digital image by using algorithms. We have already discussed many techniques to do that. Please recall thresholding, clipping, image slicing. These are the methods. Filtering, that is your uh, linear filtering, non-linear filtering. So those are used to enhance the quality of the digital image. So that is called the image processing. By using some algorithm, we uh, use image processing process to modify or enhance the quality of the digital image. Pre-processing includes activities like filtering, noise reduction, and color correction that enhance image quality and information extraction. We know that there are some filters, low pass filter, high pass filters. So they are used for uh, uh, boundary sharpening, noise reduction, and color collection. So image processing is used. The aim of the image processing is to enhance the quality of an image. Color and pixelation. In digital image, a frame grabber is placed at the image plane, which is like a sensor. So as we discussed in the last slides, there is a frame grabber. You can also know that it is a sensor. It is like a sensor. It aims to focus the light on it, and the continuous image is pixelated via the reflected light by the 3D object. So you know that an image consists of a number of pixels. The pixel is the smallest unit of an image. So an image consists of a number of pixels. And when the mapping is take place from the 3D object to the 2D plane, the the pixel pixel each pixel is pixelated, that is mapped, which is a continuous process. The light that focus on the sensor generates an electrical signal. Each pixel that form may be colored or gray depending on the intensity of the sampling and quantization of the light that is reflected and the electrical signal that is generated via them. So as you know, from sampling and quantization, sampling is the location and quantization used to find the exact color of the pixel. So to get an exact color of the pixel is important while mapping. So that process is known as the quantization. All these pixels from a digital image, uh, uh, the density of this pixel determine the image quality. As I discuss again and again, the density, the number of pixel in unit area. The number of pixel is unit area is known as density of that area. And if the number of pixel is more, better is the quality. If the number of pixel is less, but unit area is fixed. If the number of pixel is less, then it reduces the quality of the image. So the more the density, the more is the clear. The more is the density, the number of pixel is more in that unit area. Suppose there are 500 pixel present in a unit area, and suppose there is a 200 pixel present in that area. The pixel size is greater, so that is why 200 pixel comes within that area. And suppose the pixel size is less, suppose 500 pixel comes in that area. So the image which have 500 pixels in a unit area is more clear, is more prominent, has better quality than compared to the pixel having, that is compared to the unit area, the image having 200 pixel per unit area. So the more is the density, the more is the clear and high resolution image we will get. So more is the density, better is the quality. So forming a digital image is not a new concept. It is also we know, in order to form an image, we need to have continuous conversion of data into digital form. So we have two methods. Sampling is a spatial resolution of digital image, and the rate of sampling determines the quality of the digital image. The magnitude of the sampled image is determined as a value in the image processing. It is related to coordinate value of the image. As we discuss again and again, that is sampling is nothing but it is associated with the location, the position of an image, the position of an image. That is position of a pixel in an image. So that is why it is written. You see here, it is related to the coordinates value of the image, the location of the image, the position of the image. So it is not associated with the gray level value, color value. It not determine the what is the color of the pixel. It only determine the location. Similarly, in other hand, quantization is the number of gray label value in digital image. The transition of the continuous value from the image function to its digital equivalent is called quantization. It is related to the intensity value of the image. As we discussed, it is related to intensity value, gray level value, color value. So the normal human beings acquires high level of quantization level to get the fine shading detail of the image. So the high level of quantization level can be applied to get the actual picture or actual color of the image. The more quantization levels will result in the more clear image. If your quantization is level is more, you will get a more clear image. You will get a more prominent image. So sampling and quantization uh, is used to convert an analog signal to digital signal. Sampling for location, quantization for color. Because each image is associated with two things. One is image location, another is image color. Image location by sampling, image color by quantization. The advantages are improved accuracy. Digital imaging is less susceptible to human factors and gives accurate output, the object with high detail capture. The enhanced flexibility we have already discussed when we are discussing the image processing. Digital images are easy to manipulate like an analog one, edited or analyzed as per the requirement through different software. Hence, they provide flexibility of post processing. So it is very easy to manipulate, very easy to editing, and very easy to analyze as compared to an analog one. High storage capacity. That is, data is in digital form, such as in one or more digital image can still be stored in large amount of with very high resolution, and quality will not suffer physically wear and tear. So high storage capacity, easy easy sharing and distribution. The use of digital image allow them to be quickly duplicated and transmitted across various channels and to various gadgets, helping to speed up the work. So you can easily share or distribute. Advanced analyze capability. Digital imaging enables the application of the analytical tools, including image recognition, machine learning, which can provide better insights and increase productivity. So, image recognition and detection, machine learning is used digital image. Although these are some merit, also it has some drawbacks. Data size. Large structured digital image could occupy large storage space and computational power, hence may be expensive. Uh, there are some image noise. Digital image may be accomplished by some by compromise by noise and artifacts which degrades the image quality, and mainly when photographed at night or using low image sensor. So there are some noise. Uh, Although we have some noise removal techniques, but and digital image contains some noise if it is photographed at night due to the lack of light. uh, uh, it contains some noise, or using low image sensor also, the image contains some noise. Dependency on technology. Digital image entails the use of sophisticated technology and equipment that may be costly and that may be constant need to service or replace the equipment. So always it depends upon the technology. Privacy concern. The ability to take the circulate photographs digitally also poses concern because personal information can be photographed without the subject permission. This is also a security issue. Then data loss risk. Digital image repositories, however, are prone and data loss caused by the hardware failures and corrupting software or all intentional erasure. So sometimes some hardware failure or software, if the software is corrupted, so data, there the risk of data loss. You may lose the data. Uh, it has some application digital medical imaging. We know that digital imaging is employed in medical fields. Your X-ray, MRI, CT scans, also the example of your medical imaging. Surveillance and security, we have already discussed. Digital camera and imaging systems are greatly needed for various security and surveillance process, as they offer live feed and also useful in acquiring data for investigations. Remote sensing. Digital image plays an important role in remote sensing application in the form of monitoring and mapping of environment and disaster, and involve data capture from satellite and aerial systems. So we can sense the sensor is used for a remote area. Entertainment and media. The entertainment industry involves the use of digital image in films, video games, and virtual reality to deliver improved visual impact. Scientific research. Digital imaging helps in scientific studies through providing best picture at research field like astronomy, biology, and material science. Then come to the important part of the computer vision. Introduction to object detection using image processing. The object detection. The object detection is a crucial task in computer vision that involves identifying the locating object within an image or video. Okay. So that is identifying the location and identifying and locating the object. That is suppose a cancer cell in human body, in patient body. The cancer cell is not present in all the part of the body. To identifying the cancer cells in a human body. Okay, that is known as object detection. Identifying and locating the object within an image or video. This task is fundamental for various applications, including autonomous driving. Autonomous driving. That is when a car is driving without a car or any obstacle comes in front of the car. That is, the car would be stopped. Okay. So that is here the it detect the object is detected. Some object is detected and identified by the machine. That is called the object detection. Autonomous driving, video surveillance, and medical imaging. This article developed into the techniques and methodologies used in object detection, focusing on image processing approaches. Then key concepts in object detection. Object localization. This involves determining the location of the object within an image by drawing boundary boxes around them. So first concept is object localization. That is to find the location of the objects. This is important. In object detection, is identifying and locating the object. So locating the object is called the object localization. Then how it is localized? By drawing a boundary boxes around the desired object. Object classification. This involves identifying the category to which the detected object belongs. Suppose you are interested to identify the vehicles. Okay, so that is it will identify the category of the vehicles. Bounding boxes. These are the rectangular boxes used to determine the location of the object within an image. The best example we see, that is there is a rectangle bounded in the face recognition system. Please recall the face recognition system in your image. So this is an example of bounding boxes. That is, these are the rectangle boxes used to define the location of the object within the image. You see here, there are some boundary, there are some rectangular boxes. You see, the chair is recognized, the cell phone is detected, the cob is detected, the person is detected. So image recognition using the most powerful object detector, YOLO. You only look once. Person 7. So this is an algorithm YOLO V7 to detect and to recognize the object of an image. You see, this is an image, and the image is recognized by drawing some rectangular boxes around them. So after that, image recognition. Image recognition is the task of identifying object of interest within an image or recognizing which category the image belongs to. Suppose we are interested in an image, we are interested to view only the vehicles, the cars, the trucks, the buses. So how to identify the object of the interested object in an image and recognizing which category they belongs. So it is known as image recognition. When we visually see an object or scene, we automatically identify the object as a different instance and associate them with individual definition. As we are eyes, the human eyes are very powerful tools to recognize them. So manually we recognize them. But the visual recognition is a highly complex task for machine to perform. For machine does not have eyes like us. So the visual recognition is a highly complex task for machine to perform, requiring significant processing power. So how does the machine do this? Image recognition work is a long-standing research problem in the computer vision field nowadays. While different methods to imitate human vision involved, the common goal of image recognition is the classification of detected object into different categories, determining the category to which an image belongs. Therefore, we also refer to as deep learning object recognition. So it is a process of recognizing the object and to which category the object belongs in an image. In past years, machine learning, in particular deep learning technology, has achieving big success in many computer vision and image understanding tasks. Hence, deep learning image recognition method achieve the past result in terms of performance, frames per second (FPS), and flexibility. We have already discussed this image. You see all the objects is identified and also recognize which category it belongs. There is a cell phone, there is a cup, there is a person, there is a chair, there is a dining table, and the image is recognized using the most powerful object detector. YOLO, you only look once. V7, this is the version 7 algorithms or detector. So the question may arise in your mind that what is image recognition and object localization? So you see, object localization is another subset of computer vision often confused with image recognition. Object localization refers to identifying the location of one or more object in an image and drawing boundary box around their perimeter. So object localization is nothing but it is identifying the location of the object in an image by drawing boundary boxes in their perimeter. So around them a boundary boxes is drawn. However, object localization does not include the classification of detected object. It does not classify. It does not include the classification of detected object. It is only used to identify the location of the object by drawing boundary boxes only. Bas. You see here, image Example of face detection with deep learning on a digital image. Only face is detected by drawing a rectangle, a boundary box around the face. What is recognition? The term image recognition and image detection are often used in place of each other. However, there are important technical issue differences. Image detection is the task of taking an image as input and finding various objects within it. It taking an image as input and finding various objects within. What are the various objects within that image? This is called image detection. An example is face detection, where algorithm aim to find the face pattern in the image. We have the examples. We have seen that picture. When we strictly deal with detection, we don't care whether the detection object are significant in any way. So we have already seen that image detection process. You see, this only determine the image. The goal of image detection is only to distinguish one object from another, to determine how many distinct entities are present within the picture. Thus, boundary boxes are drawn around each separate object. So image recognition is only to determine, to find the face pattern in the image. But you see, what are the image detection? Image detection is different from image recognition. It is only to distinguish one object from another, to determine how many distinct entities are present within the picture by drawing the boundary boxes around the each separate object. On the other hand, image recognition is the task of identifying the object of interest within the image and recognizing which category or class they belongs to. So the main difference is written in the, you see, last point. The image recognition is the task to identify the object of interest within the image. So recognition means you have to identify the object, and recognition means in which category or class those object belongs to. This is object detection. So object recognition is identifying the object of interest within an image, and image recognition which category it belongs. You see here real-time video recognition with different classes: car, truck, bus, train, using YOLOv5. Another sensor, another algorithm, YOLOv version 5. And this is the real-time video recognizing the cars. It belongs to the car. You see, so recognize the car by drawing a boundary boxes. You see, how does image recognition work? So we know what is image recognition, what is image detection. So how does it work? Using traditional computer vision. The conventional computer vision approach to image recognition is a sequence or computer vision pipeline of image filtering, image segmentation, feature extraction, and rule-based classification. But however, engineering such pipeline requires deep expertise in image processing and computer vision, a lot of development time and testing with manual parameter tweaking. So in general, traditional computer vision and pixel-based image recognition system are very limited when it comes to scalability or the ability to reuse them in varying scenario and location. So due to these demerits, traditional computer visions has limited scope because it is you have to require deep expertise knowledge in image processing and computer vision, a lot of development time, it takes more time in testing with manual parameter. So the when it comes to scalability and the ability to reuse them varying scenario. So using machine learning and deep learning, image recognition with machine learning on the other hand use algorithms to learn hidden knowledge from a dataset or good or bad samples, which is known as supervised or unsupervised learning. The most popular machine learning method is deep learning, when a multiple hidden layers of a neural network are used in this model. Some network are there, some in deep learning, some technique are there to use in this model. You see here video analysis with machine learning using algorithm YOLO V7. The person are there. You see the TV also, clock also, the electronic gadgets also detected. The persons who are standing there also detected. The introduction of deep learning in combination with powerful hardware and GPUs enable great breakthroughs in the field of image recognition. So deep learning is associated with the powerful hardware systems. With deep learning, image classification and deep neural network face recognition algorithm achieve ever human level performance and real-time object detection. Still, it is challenge to balance a performance and computing efficiency. This is also a challenge. Hardware and software with deep learning models have to be perfectly aligned in order to overcome computer vision cost. So they have the proper aligned because the computer cost is more. So that is why to overcome the computer vision cost. Therefore, the ability to always use the most recent algorithm has direct costing implication. The most powerful and efficient algorithm requires several times cheaper hardware and achieves several times better performance on equivalent hardware when compared to legacy algorithm. So some most and proper algorithm should be adopted for better performance. So in computer vision, we have already discussed. So let us discuss what is human vision. Human vision system. We know that in human vision system, the human eye is plays a vital role. So the human eyes, we are discussing the human eyes here. The human eyes in the nearly spherical in shape with a 20 mm diameter on an average. And the main three parts of the eyes are the cornea and the sclera outer cover, the choroid and the retina. You see the image, cornea is there, iris there, retina, blind spot, visual axis, lens, eye lens, anterior chamber. So as we see here, the sclera is a opaque member that encloses the optic globe all around except at anterior end, which is covered by the cornea. The cornea is the top transparent cover of the anterior chamber. Choroid is the layer under the sclera. The membrane choroid contains a network of blood vessels. These blood vessels from the major source of nutrition of the eyes. If we know that if there is any harm in that blood vessels, it it damages our eyes. If the choroid is damaged or inflamed, it can restrict blood flow in the eyes, resulting in serious damage of the eye cell. So if the choroid is damaged, it restricts the flow of blood because it is responsible for flowing blood to our eyes, which supply the nutrition for the eyes. So the role of the choroid is also to control the amount of light entering the eyes as well as reduce the backscatter inside the eyes. So it is also control the amount of light entering because we have the capacity, our eye has a capacity to receive the light up to limited intensity or limited brightness. So this role of choroid is besides that it control the amount of light entering to our eyes. The choroid is divided into two parts. The ciliary muscles, which relax and tighten the enables the lens to focus by changing its shape. We know that the eye lens, which focus to the focal point, if the object is nearer to us or very far away from us, it does not matter. That is the we can view the object easily. If the object is nearer to us, we can also view it. If the object is very far to us, also we can view it. So lens is adjusted in such manner to this purpose. The iris in diagram that contract and expand to control the amount of light that enter the eyes. The lens is transparent biconvex structure that helps to refract light into the eye so that the image is formed on the retina. The lens is flexible and can change shape to change the local focal length of the eye. So the lens is flexible as we discussed, irrespective of the distance. It change the shape to change the focal length of the eye. That is, it if the focal length does not change, we may not see the some object. So this ensures that object at various distance can be focused upon and their image can be formed in the retina. So it is adjusted in such a manner that irrespective of any distance, that is that is focus upon, and the image can be from the retina so that we are able to see that object irrespective of the image. If the image is 20-meter distance from us, we can view it. If the distance is 50-meter distance, also we can view it. If the image is 100-meter distance, also we can view it. So this is the uh, work of eye lens. The retina is the innermost membrane of the eye. It lines the wall of the complete posterior portion of the eye. The retina can be thought of the image plane in the eye. Since on properly focusing the eye on the object, light from the object is passed through the lens so that the image is from the retina. As we discussed, light from the object is passed through the lens and the image is formed in the retina. That is, the lens is adjusted in such a manner that the image must be formed in the retina. Otherwise, we are not able to view it. So, irrespective of the distance, the image is formed within the retina. The retina also consists of two type of cells called rods and cones. The cones are highly sensitive to color and are around 6 to 7 million in human eye. You see, 6 to 7 million in human eye. That is, it is sensitive to color, and the cones are located on the fovea, which is the central portion of the retina. So that object is focused in that focal length. So the image is formed in the retina, so that we can able to view it. So surprisingly, there are 75 to 150 million rod cells which are completely distributed all over the retina. The rod cells give the overall picture of the object on the scene and reduce the amount of details. Rods are also responsible for low light vision, also known as scostopic vision, which cones are responsible for bright light vision and also called photopic visions. So the rods are responsible for low light visions, whereas the cones are responsible for the bright light visions. In the human eye, the distance between the retina and lens, that is the focal length, varies between 14 and 17 mm as the refractive power of the lens increases from minimum to maximum. So this is the distance from between retina to the eye lens. That is called this distance is called the focal length f, which varies from 14 to 17 mm. For a nearby object, the lens is most strongly refractive. Moreover, the lens of the eye is very flexible and is flattened by controlling muscles to enable the eye to focus on the distance object. As we discussed, irrespective of any distance, the image is formed in the retina uh, because the eye lens is very flexible and it is flattened by controlling the muscles to enable the eye to the focus on the distance object if the object are very distance. So lens also plays its responsible role, a vital role to focusing that object in the retina so that we are able to view it. Color fundamental. Let us see how the color is formed. What are the different colors in an image? Every color is defined using three quantities that are independent of each other. However, taken together they define a particular shade of a color. Let us discuss what are the components, the three components. Hue. Hue component is color is defined by the dominant wavelength. The wavelength range on the electromagnetic spectrum that defines the visible color spectrum lies between 400 mm nanometer that represent the violet color and 700 nm that represent the red color. So 4 nm to 700 nm wavelength. You see here. Visible spectrum in between 400 mm to 700 nm. If we go the longer wavelength, that is the infrared, 1010 to per QNM, radio waves which is not visible to us, it is 10 to 9 to 13 nm, 10 to power 9 to 13. So that is why it is not visible. Only visible spectrum is to 4 nm to 700 nm. Blue color you see 436 nm, green in between that about 546 I think, 546 nanometer, and red is 700 nanometer. And if we consider the shorter wavelength X-ray 10 to power minus nm which is not visible, or gamma rays which is 10 to power minus QNM which is very shorter, which is also not visible. You see ultraviolet also 10 to power 1 nm which is also less, and only the visible spectrum are 400 nanometer to 700 nanometer. So second one is saturation. The excitation purity, purity of color is determined by the quantity known as saturation. It is depend on the amount of white light that is mixed with hue of that color. A fully saturated color implies that no white light is mixed with that hue. So it depends upon the amount of white light is mixed with the hue. This chromaticity. The sum of hue and the saturation constitute the chromaticity of the color. Therefore, if there is no color, it is called achromatic light. Intensity. The amount of light actually present define the intensity. Therefore, intensity is a physical quantity. If more light is present, the color is more intense. Achromatic light has only intensity but no color. Grayscale image have only intensity. Luminance or brightness. The perception of color is the quantity known as luminance or brightness. For example, given two colors of the same intensity, such as blue and green, it is perceived that blue is much darker than green. So this is called the luminance and brighter. So that is blue is more dark, green is more brighter. Reflectance. The ability of an object to reflect light is the reflectance property of the object. The reflectance property determines the color of the object since we see that the color that are reflected back are not the ones that are absorbed. For example, an object that reflects green absorbs all other color in the white light and spectrum except green. So we know that the color also absorbs some light. So you know that the white color absorbs less as compared to a black color. So that is why we are advised to wear white color in summer. It absorbs less heat. There are about to 6 to 7 million cones in the human eyes, and they are responsible for recognizing colors. So, as we discussed, 6 to 7 million cones in our human eyes, which are responsible for recognizing color. Nearly 65% of the cones recognize red. 33% is sensible to green, and about 2% is to blue. Red, green, and blue are known as the primary color, and any other color are seen as a combination of these primary color. So this we know that RGB, red, green, and blue are the primary color. Any other color you see, that is nothing but the combination of these three primary colors. However, there is a difference between the primary colors of light and the primary colors of pigments. The primary colors of light are red, blue, and green, and then can be added to produce the secondary color of light that are yellow. Suppose yellow is nothing but yellow can be produced by combining red and green. If you combine red and green, yellow color will be produced. If you add red and blue, magenta color is formed. And if you add green and blue, cyan color is formed. So every other color are formed by combining these three primary color RGB. Moreover, the primary colors of pigments are said to be those that absorb a primary color of light and replace the other two. Therefore, in this case, the primary color are cyano, magenta, and yellow, while the secondary color are red, blue, and green. For standardization, in 1931, the Commission of International Dear Raja CIE defined specific wavelength for the primary color. Red equal to 700 nm. We have already seen that slide. So which is visible spectrum 400 to 700 nm. So red is the 700 nm, blue is 435.8 nm, and green is 546.1 nm. So the amount of red, blue, and green required to form a color are known as the stimulus of values and denoted by x, y, and z. So given x, y, z, the stimulus of coefficient which define a color. If we define x, y, z as the relative values of the primary color, then this value can be found by capital X equal to capital X by x, y, z, then y is equal to y by x, y, z, and z equal to z by x, y, z. It is observed that x plus y plus z equal to 1. So if we specify color as the combination of x or green, then it is given by the values x and y. The values of z can be computed z is equal to 1 minus x plus y. Consider the coordinate of warm white 0.45, 0.4, and the coordinate of the deep value in a find the percentage of the color red x, green y, and blue z. We first we know that the trichromatic coefficient xyz which is given, so z equal to 1 by x plus y, so 1 minus 0.4 because all the addition of all three are 1, so z equal to 1 minus x minus y, so it is 0.15. Now the stimulus values x equal to x by x plus yz, y by z, and this is the value 0.45, 0.4, 0.15. Hence, x is to y is to z equal to 0.45 into 0.4 and 0.15. Therefore, the percentage is 45%, 40%, and 15%. So, if the coordinate axis is given this manner, you will calculate them. Some color models. The human eye The principle of absorption of color of any of the model by human eye by any is called color model. The human eye has absorption classified colors and recognize them as variables. Those are red, green, and blue are called primary color of light. You already know RGB as known as the primary color. The secondary color of the light is produced by adding primary colors. For example, red and blue produce magenta, red and green produce yellow, green and blue produce cyano. So proportion of primary and secondary color in appropriate amount produce white light. Let us see the RGB model. The RGB color is based on the Cartesian coordinate system where the color subspace is Q with axis representing the red, green and blue. A color in the RGB model is therefore specified in three tuples RGB, where RGB represents the amount of red, green, and blue respectively present in that color. The geometry of the RGB color model is shown in the picture. We'll see that picture in the next slides. It will assume that all color values are normalized. That is, it is unity cube and all values of R, G, and B lie between 0 and 1. It is clear from the figure that is the model of Q with the three axes of red, green, and blue. The gray label value lies in the diagonal of the Q, which join the black 000 and white 1 and 1 vertices of the Q. Let us see. You see the black color, which is the origin, that is 000. You see the x-axis, g-axis, RGB, G is the middle, so it is 0, 1, 0. And you see the white color, the coordinate of white color, that is 1, 1, 1. Here, value of G is 1, B is 1, and R is 1. And you see the cyano color, cyano is 0, 1, 1. Similarly, yellow you see, yellow is R is 1, G is 1, no B, 1, 1, 0. So this is a color Q from which you can get the information about the different color. In RGB image, the R and B components are at mid and the G component is at 1. Then what color would be seen by the person? In RGB image, the R and B component are at mid and G component is at 1. Which color would be seen by a person? At the given point, we have R by 2 plus B by 2 plus G. So R equal to R plus B plus G by 2. If we take half common, so RBG plus half is equal to mid gray plus half G. So mid gray plus half green, pure green with some gray component. So we can view some pure green and some gray component. So if the question is the RGB value at the middle and G component is at 1, that is 0.5, 0.1 and 0.5. So you will see a pure green color with some gray component on it. So as we know, The primary colors are RGB, but primary pigments are CMY. That is your cyano, magenta, and yellow. The CMY model is because the CMY color are formed by combining RGB. If we combine R and G, yellow is formed, blue and green, cyan is formed. So the CMY model is a subtractive model. A color from a white light and reflects the rest. For example, when white light is reflected on cyan, it subtracts red and reflects the rest. While RGB is additive, you know that the cyano, when the white light is reflected on the cyano, it subtracts red and reflects the, because white is the combination of all the three. So when it subtract the red and reflect the rest, while RGB is the additive model where something is added to black to get the desired color. CMI is subtractive model. So the conversion between CMI and RGB model is given by the equation CMI equal to 1 minus C is equal to 1 minus R, M is equal to 1 minus B, and Y is equal to 1 minus G, and it is written like that. C is equal to 1, 1 C, then 1, 1, 1, then minus RGB. So cyan color is 1 minus R. It is subtract red and reflect all the three. Similarly, magnet color will not blue, it reflects R and G. Similarly, Y is 1 minus G, that is, it reflects R and B. Where the RGB values have been normalized, THSI is this is method is this THSI, this it is written mistakenly THSI. Gives a method to convert the RGB to CMI to enable printing hard copy. Since the CMI model is used to printer and plotters, you see this is red color, red and green is added to give the yellow color, and all the three are added where all are the common. A intersection B intersection C is white, and the corresponding CMI model, white is converted to red by subtracting from 1. You see white is equal to 1 minus 1 0. The yellow is blue, and blue is yellow, red is green, green is red, and vice versa. Same thing is written here. Hue saturation we have already discussed. You see, this is the blue, red, green, blue and red from magenta, blue and green from cyano. This is the HSI model. Hue saturation intensity. So students, please write your name. Who have not written, please write your name and registration number. Please wait a while. I will take the snapshot.